and welcome. In this new chapter, let's discuss the advanced file I/O operations. The different topics covered in this chapter are: we will study about atomicity, race condition, we will describe about FCNTL system call, what is blocking and non-blocking I/O system call, what is file descriptor table and open file table. Then finally, we will see what is the inode of a file. Before we discuss the concept of race around and atomicity, let's have a look into what is about multiprocessing or multithreading. Linux operating system provides a multiprocessing or a multithreading environment. This means there are several processes running parallelly in Linux system. Each process has its own priority, and based on the priority, scheduler gives every process a definite amount of time on the CPU so that the process can execute. Hence, overall, the user gets a virtual feeling that as if all the processes are executing at the same time and in parallel. Now, in a multiprocessing environment, there arises some issues such as a race around condition. A race around is a situation where the result of different processes running together on a shared resource can behave in an unexpected way. Or in other words, we can say that when several processes are running in a multiprocessing environment, and if more than one process are utilizing the same resource, then there can be a chance of output being unpredictable. This is called a race condition. So each process has to race to access the resource and process on the resource and perform and to provide an output. So a situation will arise when the process are racing to finish the execution. We will discuss with some examples in order to understand the race condition. Let's begin with the simple example. Here on left hand side we have program 1 and on right hand side we have program 2. Both programs are identical in the sense each program will open a common file called log.txt in read-write mode. And let's say that we are going to write 1,000 bytes of data on the same file using a write function. The same thing we are doing in program 1 and program 2. Now, scheduler schedules each program 1 and program 2 according to the scheduling algorithm. Let's say that scheduler has scheduled a program 1 and program 1 has completed the first line and it has opened the file in read-write mode. Now before writing to the file, let's say that scheduler time was expired and the scheduler has given program 2 the CPU time. And now the second program has opened the same file in read-write mode and it is about to write 1,000 bytes of data onto the file. Now assume that step 1, step 2, step 3 is finished in program 2. Now the CPU time is given back to the program 1 and program 1 starts at the point from where it had left earlier. So it starts the execution from step 2 and now it starts to write buffer of 1,000 bytes. But previously the program 2 has already written 1,000 bytes of data onto the log file. But now program 1 rewrites or overwrites a new set of 1,000 bytes onto the log.txt file. So as a result, there is a race between program 1 and program 2 to access the log.txt, which is a common resource. And the output of this could be unpredictable and it depends upon the scheduler scheduling the process. So in the same way, Let's take one more example of race condition. Let's say that the goal of the program is to create a file, basically to check a file for its existence, and if the file is not present, then create a file and print whether it has created the file successfully or not. So now we have two identical programs running parallel. Now let's assume that program 1 opens a file in read write mode and checks whether file is present or not. And now if open system call fails, then it has to create a file. And after creating a file, it prints file creation success. Now let's say that the scheduler has given program 1 the scheduling time and it has performed open system call and checked if the log.txt file exists or not. Before processing to the next system call, let's say that the scheduler has given the scheduling time to program 2 and the dotted line says that the program is waiting for the CPU, whereas the hard line says that it is in executing mode and the CPU is executing the program. Now the program 2 which is waiting has got the CPU time and it has executed and it has checked for the file that needs to be created, and now the file fails and now the open fails. In this case, because the file does not exist and it goes forward and opens a file and it creates the file because of o_create flag, and then after creation of the file it returns success to program 2 saying that the program 2 has created the new file. Now after printing success, the scheduler has given scheduling time back to program 1. Now the execution starts from this point where it is about to create a file. So the open system call here fails because the file is already created. Even though open system call fails, since we have not given a o_execl, the open system call here returns a positive value and prints successful message in program 1. So the user who is running both the program parallelly is in a feeling that both the programs has created the required file. Program 2 also says that it has created the new file and program 1 also says that it has created the new file. But the fact is program 2 has created the new file and program 1 has not created the new file. So this is a problem of race condition where both are claiming to have created the new file. Thank you. In the next video session, we will study about atomicity. Thank you.